All right, so welcome everybody. We are very happy to have you here in Geneva. Thanks to all the speakers and the participants here. So this workshop has been supported by the SNF project called Space-Time and Causation in Quantum Gravity, led by Baptiste Levian. And the idea was to gather experts who works on the topics of quantum gravity, laws of nature, all related concepts, to see whether there's a way in which we can still talk about laws of nature in the very exciting yet very complex environment of quantum gravity. And one of the first reasons why people started challenging this view is that it looks as if standard accounts of laws of nature seem to somehow be based on some kind of notion of space-time. And if the lesson of some of these approaches is that we should be ready to renounce to certain notions of space and time, then the question is, can we still speak about laws of nature? So without losing further time, let me just say one very important thing. Do not drink the tap water here because it's not drinkable. There's a lot of water. If we need more, we will buy, but just do not drink it. Let me thank Baptiste and Chris and all the PhD and postdoc students who decided to help us with the organization. So I'll give the floor to Professor Alexandre Guay. Thank you. Yeah.
Okay. It's my great pleasure. Hello, everyone. Good morning. It's my great pleasure to introduce Professor Guay from the Catholic University of Louvain. And the question he's going to address is there an explanation of change? The floor is yours.
Okay, thank you very much. I would like first to thank the organizer, Baptiste and Emilia. Thank you very much to have invited me, and I have to say from the beginning that it's really a work in progress. They asked me first, it's not their fault, they asked me first to present a published paper, and I don't do that anymore because I don't travel a lot. So when I have the opportunity to travel, I always try to defend something. And so it's a work in progress. That's life. So what will be my question? My question will be, is there, and we will get to quantum gravity and laws, be reassured. My question is that, is there a general explanation for change? In general. So that's a typical Aristotelian question, but also change seems necessary for the concept of measurement. So if you claim there's no change at all, or change is not explainable, or blah, blah, you have to explain, to go a little bit further to explain how we measure and blah, blah. So my question here will be, and this will be the fil rouge of my talk, is there a physical or a metaphysical explanation of why change in the more general sense? This question will take two forms, depending on the contrast class of answer. Why is there change rather than changelessness? Changelessness. I don't know. I stole this word to Gordon Bella, so I don't know if it exists in English, but it seems fine to me. Changelessness is more than the absence of change. It's in a certain way no potentiality of change or something like that. Or you can put it in a causal way. What is the ultimate cause or source of change? Okay. The plan will be like that. I will first discuss the explanandum, a little bit more about the notion of change itself. I will discuss why I believe that physical explanation of change fail or incomplete. Then I will put some constraint of the notion of change, and here there will be some consideration of general relativity and quantum gravity. Not as much as you would like, I know, but I don't know what is quantum gravity. It's a speculation, it's philosophy. There's not a lot of data, so it's complicated to me. After that, I will switch to metaphysical explanation of change, using these constraints to show how metaphysical also fails, but trying each time that I point to a failure to see what should be done, and maybe a conclusion, if I have one at the end of this discussion. So that's the plan. What is change? Unfortunately, change is not a theoretical term in physics. It's not a term of the art. There's not a science of change. There's not a theory of change. So what we can find in physics, it's representation of different change but we don't have, it's not like electrons. It's not a term inside a theory. So what do we see in physics? We see typically function of time, probability amplitude, things like that. These representation of change, are highly compatible with a very famous definition of change by Russell. And here I put too much text on my slides, but it's because now I'm doing more history of philosophy and it's a professional deformation. But it's interesting to return to the definition of Russell. Change is the difference in respect of truth and falsehood between a proposition concerning an entity at the time t and a proposition concerning the same entity at the time t prime. So to have change, you need two things. You need an index, typically time, and you need an identity criteria. You need to know it's the same thing. Or you cannot build this proposition. You cannot evaluate if it's true or not. A little bit later, Russell explained what it means for motion, and here he's just reproducing Guillaume d'Occam. How do we say Occam in English? Is it Occam too? The same medieval guy? It's just the definition of Occam in a modern term. Motion consists merely in the occupation of different place at different time. There is no transition place, no consecutive moment, blah, blah, blah. So in a certain way, there's no flow of time. Okay, so as I said, when we look at representation of change in physics, it seems compatible with this definition, but it could be compatible with other definitions, because I repeat, and that's an important point, change is not a physical concept. Okay? Electrons is a physical concept. Mass is a physical concept. There's no physical theory of change, to my knowledge. Okay? So when we don't know where a concept is coming from, we go to the manifest. And here, Christian will recognize a common origin in our training. We go to Sellers. And it's not a big deal if you don't read Sellers, but everybody coming to Pittsburgh is trained in Sellers, and it's just our way. So what is the manifest image according to Sellers? It's not the original image, it's not the traditional, just the cognitive structure in a neo-Kantian way. It's also a cultural thing. It's the way we build our fundamental concepts. And in particular, the fundamental ontological notion of the manifest image according to Sellers, it's agent. So the first thing you see, it's stuff, doing stuff for reasons. So if you have this notion of the manifest image, what is change? To be an agent, a person in the vocabulary of Sellers, is to have the capacity to situate oneself within the space of reason. It also involves the ability to act in accordance with the reason. Often action form a cohesive plan aimed at achieving a specific goal. In this context, each action within the plan serves as a unified component, and an action is the primitive notion of change in the manifest image. So what kind of change do we have when we abstract from the manifest image? We have in a certain sense an idea of change as unitary metaphysically. Change is not a succession of things. Change is something starting somewhere, finishing somewhere, which is, according to White, compatible with the Aristotelian notion of change. In claiming that a continuously moving body is at such position only potentially, Aristotle is simply saying that there is a legitimate sense of the modal could, for which it is true to say that the body could have stopped there, but in fact did not. So now we have change as a difference, according to Russell, without becoming, change as a being, let's say. And we have change as becoming, coming from the manifest image, which is, it's not a succession of steps, it's a complete thing. And I don't know which one is the real one. We don't have enough constraint, to my knowledge, to really choose now, at least at that point of the talk. Okay, some remark about this explanandum. At least when it applies, the notion of change and kinematic possibility in the Lagrangian sense are pretty close. Change can be identified to a subset of the kinematic possibility when it applies. The role of time in the concept of change is open to debate. Do we necessarily need time as an index or another index or another order parameter? Is it still change? It's still open. And physical representation of change that I discussed first are compatible with both notions. You know, a function of time could be interpreted in many ways. A discontinuous change in quantum mechanics could be interpreted in many ways. Okay, so that's the end of my first part. Oh, I forgot to say to you, if you need precision or something is too fast or it's not clear, because I know it's the first time I do this talk, please arrest me and ask. So that's the end of the first section. Everything is okay? People are smiling. This is weird. People do not smile usually when I do talk. Okay, let's continue. Maybe there's a strange vibe in the room. Maybe it's the water. Physical explanation of change. So let's see how a typical physical explanation of a particular change, an eclipse. There's many theory of how to connect explanans with explananda, but most of the time, most theory will use the same kind of explanans, depending on the way to organize them. So typically, you want to explain a particular eclipse. In your explanans, there will be stuff like past and future celestial positions, scientific law, dynamical or structural regularities. Okay? That's typically what physics does. For these explanations to valid, this is my claim, it is necessary to assume, if not the existence of time, at least the existence of regular change, even if it's only in a static sense. So in fact, these explanations to work presume that you already know what change is. Why? Because physical law, in the way they are written, they are covariation between quantities. So they are not efficient cause. They cannot participate in an efficient cause explanation. They are formal cause. The Maxwell equations are saying to you, if things vary that way, this quantity of magnetic field vary that way in time, that's electromagnetism phenomenon. It does not say to you anything about causality. If you say, oh, field acts, blah, 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 that's, you go beyond the physical law. You have a metaphysical interpretation. So my claim, and this is in Renoir, by the way, Renoir, just for the anecdote, is the guy that had my job in the 30s in the same department. So in fact, I'm just repeating the same thing without realizing, because I discovered that before, saying, oh yeah, I'm quite brilliant, I thought about that. No, the professor giving the philosophy of nature class in my university in the 30s had already everything okay. But he was a neo-Thomist guy. I'm not a neo-Thomist, at least. There's a difference. Okay, so this is pretty bad. This means that internal to physics, the way we do physics today, does not mean that science is unable to do. Some science are pretty causal in their construction. But physics, we're not like that. Physics is building, we got abstracted from causality, and that was a good thing. We managed to modelize more stuff that way that we could with just a mechanistic metaphysical position. On the other hand, it made explaining change very difficult. To the point that even if we generalize, I say change in the universe, that's my exponenda. Exponents boundary condition of the universe plus some structural laws. All these scientific explanations of change inherently assume the existence of change itself. At most, these explanations help us to understand one type of change relative to another, why this one rather than this one, but they do not address the concept of changelessness at all. And that's okay, that's not their job. Maybe that's the job of metaphysics. But the other one is more fruitful. You remember the other one was, is there a causal explanation of change? What is the ultimate cause? So here, I'm in the University of Lemaitre too, so you see Lemaitre influence in what I say. I'm really influenced by From dead professor of my university. Okay, so could we say maybe that change could have emerged spontaneously, at least in a moment, or I don't know, at the beginning of space and time, from what can be described as chaos, referring to the concept of order through fluctuation that was developed by Prigogine and Nicolis and other guys from a competitive university in Belgium. So that's typical, because that's the way we explain a lot of new phenomena coming in physics. It's through this notion of order through fluctuation that is part of the physics of organization. However, this is just a suggestion. To flesh it out, you will need to characterize what is this chaos, what is this initial condition where change happened. Maybe it's a cosmological question. And what about, what happened to conservation principle? Where were this energy before? Or was it coming in occurrence now? And how to make this explanation non-circular. So I think this, probably this thing is more fruitful, or at least it seems better than the precedent one, but I don't know how to make it convincing, because you need more details about cosmology, cosmological model, and how they characterize the initial condition of the world. Okay, change 2.0. Wow, I'm going very fast. I should ask, are you okay? Is still, everybody understood and everything? Oh, you're not smiling anymore. Weird. Okay, now it's the part, the more weird, it's the part that I have the more difficulty.
It's a question.
Oh, yes. Sorry.
Can we discuss later, because otherwise I have a question now.
If it's just a precision question, you should ask it now. If it's a discussion question, it should be at the end.
So I ask the question, and then in case you postpone it.
Okay, I can decide if it's a precision or not.
Okay. I'm not sure I understood why the second type of explanation would actually be an explanation.
It's a causal explanation.
So why would it be different than, again, assuming
So you
there's been some...
could do something like, you have here a bifurcation or something like that.
Mhm.
If you believe that this kind of explanation is an explanation for behavior like self-organization in fluid, for example, it's the same pattern. However, if you say that you disagree that this is an explanation, even in fluid physics and solid state physics, we can discuss, okay, maybe it's not enough. You see the point?
I see the-
But it's an analogical explanation to other thing we consider explanation in solid state physics and fluid physics. Order through fluctuation. You have a system, there's fluctuation, there's not, and suddenly you have a common behavior of the fluid, for example, and you see that's new. This process of order through fluctuation is the explanation. However, if you say this is not enough for an explanation, I would agree with you. I would say, okay, so that won't work. I don't know about that. It's a kind of physics that we mostly do not study in philosophy of physics, so we'll see. Okay, 2.0. Physics alone does not determine what is changed metaphysically, but it can potentially, and here I insist on potentially, put constraint on such answer. Let us begin with what we could learn from time reversible physical theory. And here I will do something that I usually say you should not do, to read some metaphysical conclusion from physical theory. So everything I will say in this section is if, maybe. First, I'm pretty optimistic that special relativity will survive to any development in a form or another. So if the world, if special relativity is really the way the universe is, I'm not interpreting hit very generally, is there space or times or not? I'm just saying there's some quantity that vary in a certain way. Is there a lesson about change about that? Potentially, it means that time is a local thing. So time, and that's the move of Einstein, and a lot of neo-Kantian, when they read Einstein, it's the way they interpret it, that Einstein was claiming time is the thing, the measure of the thing doing stuff, though it's a local thing. Time is strictly defined as a measure of change in a specific clock, or whatever is a clock for you. So, if that could be a constraint on change, as temporal change is fundamentally local, and when we have, more general change at long distance, we have to go to a relational aspect of change. So different change, different local change generate by their relation a change at longer distance. First potential lesson. Second potential lesson. From the constellation of problem, we call the problem of time in general relativity. So maybe it's a problem of the formalism, but if it is a real thing, if it's a sign, a clue of something that histories could be timeless, and they could be histories in the sense of the Lagrangian approach. And here I put the definition of Belot of the problem of time. If we have such a thing on both the space of solution and the reduced space of solution, we face the usual problem. Point of this space represent history timelessly, so no function of such space can represent in a direct way a change in the physical quantity. If this survives in a form or another in the future of physics, that will mean that temporal change connected, indexed by time, is at best contextual. Gauge dependent, statistic dependent, you need a mechanism to explain the context. Okay. And third potential. Okay, here's the quantum gravity. So I don't know what is quantum gravity. I studied quantum gravity. When I was a physicist, I had class of quantum gravity. But without a lot of data constrained from the world, it's pretty difficult to know what is the right formulation. So here I will just put my favorite one, and we can discuss why it's my favorite one, but I wouldn't claim I'm right. It's just my favorite one. So low quantum gravity, it's my favorite version of quantum gravity, but this could be discussed. I don't know what is quantum gravity. So if you buy loop quantum gravity, covariant loop quantum gravity, it seems that to define change in a robust way, you will have to get rid of time or to put time as a dependent variable. And here I have the long text of Valéry and Vidotto saying that their theory is not a theory where there's no change, because of course you need change, you need difference to measure stuff, you need change to measure. But it means that the evolution and change of the real world are too complicated to be well represented as evolution of a single variable. So the lesson, if they are right, who knows, is that change is not necessarily parameterized by time, so you should be able to at least in your metaphysical position have the space, the conceptual space to have change without time, and time is possibly emergent. Something happened here. Time is possibly emergent. Yeah.
For the record, I think that the sentence can be applied literally except the quantum word to classical general relativity.
Yeah.
Indeed, we agree. And so there's no real change from what this is expressing to what Belot was saying.
Yeah.
And in fact, the quote by Einstein literally would apply in general relativity as well. And
I agree.
all of them have to do with the statement that any motion
I agree,
have
but
to be relational.
I agree, but absolutely. This and this, pretty much same thing, if you already buy a lot of background assumptions. I just wanted to put them separated because sometimes people would say, there's no real problem of time. and I buy some version of loop quantum gravity. So I just wanted to be
You may say
to
there
be
is a
there
problem.
in case. But I see how, for me too, the two problems are the same.
You may also say that there is a problem of time if you think of that as a coordinate, some variable on a manifold, and the solution is in the statement by Einstein at the very beginning that defines what we have to mean by time, which is the reading on a clock. And you take that and you apply to all the other
I agree.
concepts. There's no loop quantum gravity or
I agree.
covariant. Or
But that's the
harmonic.
problem. That's the problem for me. That's the problem. It's not the problem. I agree with you. but here, I think the lesson to be it's time. It's local. So it's not the parameterization of the space-time manifold. It's the way we understand time. It's through the measure of change. But after that, we go to geometry, and people begin to discuss geometry, and they discover this problem of time that is related to the previous. That is in part solved by this one, but not completely. If you want to look time on large scale. And here, since they start from general relativity, of course they get the same problem. We had the interpretation of general relativity because they are closer to general relativity than superstring theory, for example. They don't start with the same basic assumptions. So, of course, in a certain way, all these problems are related. But I wanted to not to force the public to buy my reading of these problems and just to see potential lesson we could from different part of physics. Okay? But I agree with you. It's normal they get they could have renounced to change altogether, but it's normal they get to that problem if they already bought this one. And they do. Okay. Is it clear?
We can discuss.
Okay, potential lesson from time asymmetric physical physics. Irreversible physics has received far less attention from philosophers, which make the lesson we can draw from less widely agreed upon. So now we have a pretty good understanding of the articulation between part of physics that are described with the symmetry of time, part of physics that are not the case, and we have two options, two interpretive options. And here I think Gajin as presenting the two options. First, or we say the fundamental theory is the time symmetrical one. So when we have these phenomena, stochastic theory, Markov chains, blah, 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 we have to add stuff, add condition, past hypothesis stuff. Or the second interpretation is that we start from asymmetry of time as a fundamental stuff of the world, after all. It's pretty what we see empirically. And in that case, we have to explain why these idealizations are so successful. Classical physics and quantum theory. So we have both. So most philosophers of physics, it's my impression, they start from they consider that the symmetrical physics is more fundamental, and they try to explain the direction of time with assuming more hypotheses. And a lot of people in the philosophy of biology or in philosophy of complex systems, they start from the asymmetry and they try to explain why at small scales time reversible stuff works. The only thing that is interesting here about change is that if we choose the second option, the Prigogine option, so irreversibility is a fundamental empirical fact. This diagram becomes self-consistent. So we have a difference between memory and projection, so there's a direction for us. We modelize the world with dynamics, for example, time symmetrical equations. We put the direction of time by hand in them when we want to modelize phenomena that have a direction. This led us to the notion of dissipative structures, so to the notion of systems that manage to keep their state far from equilibrium for a long time, typically biological systems, things like that. The success of this convinced us that there's such a thing as dissipative structure in the world. That implied that there's a broken time symmetry, because here the symmetry of time is fundamental, which explains why we are a dissipative structure. And our memory, blah, 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 is explained by the fact that, yeah, we are temporals being modelizing temporal stuff in the world. Okay, if we choose the second option, in that case, the static conception of change must be supplemented with the local privileged direction of time. So how to do that, blah, blah, blah. Or the procedural conception of time has nothing to it. Okay, so these are all lessons. I don't know which one are the best one or the more important one. It's why it's a work in progress, I don't know. Now, metaphysical explanation of change. So the primary approach to explaining the existence of change in metaphysics involves proposing a model structure to account for it. In contemporary literature, this explanation is often framed through the conception of dynamical laws of nature, or laws of nature. So now I will discuss different metaphysical conceptions of laws of nature and how they do to explain change. Okay. I was planning to do regularism. I know that a lot of people will do regularism according to the title of their talk, so maybe I should go fast on this one. That's my version of regularism. Okay? So a contingent generalization is a law of nature if and only if it appears as a theorem or axiom in each of the true deductive systems that achieve the best combination of simplicity. That's right. If Lewis had stopped there, it would be very close to John Dewey conception. But of course, Lewis is not a pragmatist. He had a lot of metaphysical stuff for the system to work. He had the idea that there's only perfectly natural properties that form a unique instantiation mosaic. So there's some kind of stuff, organization of the instantiation of properties. He had physicalism, so of course the perfectly natural properties has to be accessible to physics, or there's no empirical base to the thing. 3, you exclude by definition emergence, so it's a really mereological system. One of the problems with quantum mechanics will come to modelize that in quantum mechanics, but I won't talk about that because I think the next speaker is talking about that. The next speaker is. So no emergence whatsoever, everything supervene. And of course, past, present, future facts or ontologically on the par, because if they are not, you won't be able to use that in an efficient way. So I won't discuss the detail, I'm just saying this is his position. It explains change in an elegant way if you buy everything he's proposing. Once identified, the laws describe a non-contingent change between perfectly natural instantiation, property instantiation, at least in a static sense, so using the static conception of change, and it's perfectly fine. Some difficulty. Where does the geometrical organization of the natural property originate? This mosaic is organized in a certain way. Is it spatially organized or temporally organized? Does it depend on the geometry of space-time, which is probably, according to lesson 3, not fundamental or emergent? So in our laws of nature relative to a certain context, you have to get to the geometry in a certain way before doing the work to finding the laws. If you are in loop quantum gravity, it's even worse. This geometry is not spatial temporal, but block of enemies of the gravitational connection. So is it where? It's the same. You want to modelize physics, you should get to this theory based on the analysis of the mosaic, but it seems that the mosaic has to be defined by this theory. Do we need to already know the law of nature to define the geometry? And if you look at in the history of philosophy, it's very close to the Achmann problem. Achmann was a neo-Kantian after Einstein that saw is there a problem where you have to be geometry first, dynamic second, or dynamically first, or geometry second, or both at the same time, and what does it mean? How does it work? Second difficulty, according to the mereological reductionism, all properties supervene on these natural properties. Is supervenience sufficient to explain the potential emergence of time? it seems a very shallow relation supervenience, so maybe. If change is directed as suggested by if we adopt the Prigogine interpretation of the priority in physical laws, how can it be captured by Lewis laws of nature? Lewis laws of nature is clearly non-directional. So I don't say it's fatal difficulties, just depending on which lesson you buy, you will have a new problem to solve. Governism. So governism is that the laws govern their instance. The laws are necessitation relation between properties that are represented by universals, and these necessitation relations are exemplified in causal relations, so in change in the world. So you have this structure, this metaphysical structure of connection between properties in the Platonistic world or in the world, not important, but they are not on the same nature of the token, and they govern, they are instantiated by genuine causal relation in the world. Okay, I won't read this long argument of Armstrong, but in fact, this position is not strong enough to exclude the fact that there could be genuine causal change in the world that are not governed by laws. So some singular causal change are not grounded in laws, and there's some argument here that I don't remember. So even this Armstrong is saying, oh, maybe there's a problem in my thing. Worse than that, contextuality and the possibility of emergence of time seem to necessitate an index.
Sorry, honestly,
but put it back as it was. You know, it seems to resist to all our work. The machine.
Full screen.
Each time we bought one of these big machines in my university, we had a problem. Even if the guy is standing and saying, it will be perfect. Okay. So if you have contextuality of change or emergence of time or both, you will need an indexical conception of universals. And it's not for nothing that in 2,500 years we don't have an indexical theory of universal, because that's pretty weird. How indexical could be depending of something, of context. So Armstrong evoked the notion of quasi-universal, which is an indexical conception of universal, but he never explained the details. To my knowledge, there is one serious attempt to construct a conception of indexical universal. It's in Maudlin Metaphysics of Nature, chapter 3. He's using a geometry, a fiber bundle geometry to frame the discussion between how to compare the expression of the properties depending on where they are. But it's pretty, it's one paper that was never developed to my knowledge later. And in fact, for a lot of problem in philosophy of biology and all that, to use that kind of laws, we would need an indexical contextual observers. Primitivism. So, to the ontological question of what makes a regularity in the law of nature, I answer the law is a primitive status. If a law governs particular space-time region, then the physical state theirs will so evolve. So you say it's primitivism because it's a conception of modality that is not defined in terms of other modal terms, and it allows that laws of nature could change. Maybe it vary from one location to another. There's nothing forbidding it. This notion is pretty thin, so sometimes it's quite difficult to know how it would modelize change and things like that, but it seems, okay, if there exist fundamental laws of temporal evolution, what we call, I don't know how we pronounce it, floating? So that would explain change. Okay, how does it work with contextuality of change, with possibly emergence of time, with direction? The notion is not strong enough to really choose. However, we can look in the paper, because there's some passage of the paper, I won't read it, but it's there for your convenience, for your archive if you want me to send it, where he explained how it could justify with this notion some conditional counterfactual, which is one of the reasons we have lost. And we see step 1, choose a Cauchy surface, blah, blah, blah. Step 2, change the evolution at the Cauchy surface, apply the laws, blah, 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 and you have the variation of counterfactual. So it's a geometry first dynamic evaluator, according to the way he's using it. Exactly the same problem than Lewis. How, where this geometry is coming, since it's the laws that is supposed to produce the geometry. You presume of the geometry, and then you use the law to do the counterfactual. But that's not surprising if you defend at that time, I don't know now, he was defending some realism about space-time, so, okay. So the difficulty to account for the possibility also of non-temporal change, the indexation of floats will need to be adjusted, and my guess is that we will in that case find all the problem we had with the Lewis case analogically for that case. It's the same, because he seems to presume geometry first. I could be wrong about that. Finally, dispositionalism. So the idea of essential disposition is that properties are dispositional, have dispositional essence, and if they do, there will be some regularities that will have the necessities strained to be laws. Change occurs as the manifestation unfolds from the appropriate trigger is present. A disposition is defined by the relation between a trigger and a manifestation. It is important to note that for an essential disposition, the distinction between trigger and manifestation is logical. It's not ontological, because if it was ontological, it will reduce disposition to mechanism, and disposition are not mechanism. Okay? So the trigger and the manifestation, when we express, we define this disposition, we see a logical difference, but it's intimately related. It's in the essence of the thing. You seem skeptical. You're the metaphysician here, so. Okay. So in that case, the contextuality of change will require multi-track essential disposition and probably really, really multi-track disposition, which exists in metaphysics, but in that context, the more we have a multi-track disposition, the more difficult it is to have a criterion of identity for disposition. So that seems a problem. To accommodate good quantum gravity, we will have a relation between trigger and manifestation that does not make a reference to time or anything like that. How will we build that? Because if we have a disposition that is always on, because it's non-spatial temporal, it does not explain change anymore. So yes, conclusion. What did we learn? Or if we learned something. We learned that when we ask a typical metaphysical question, what is the explanation of change in general? We see that in the way we do physics, mathematical physics today, there's some limitation of the kind of explanation we can provide, but maybe some part of physics that are still more causal, like the time reversible physics, fluid physics, auto-organization could give us ideas to solve the problem, maybe. And if we have to adapt our notion of change to be able to accommodate all the discussion about change today in quantum gravity and general relativity, the traditional metaphysical explanation of change that are really solid, discussed a lot, developed, will have also new thing to say. You know, if you still want to be a humanism, but we will see that, you will have to adapt humanism, Lewis humanism to make sense in that case. If you are an Armstrongian guy, you have to have an indexical notion of universal. If you are a dispositionalist, I know that now all my postdoc and students are dispositionalists. Dispositionalism is the main thing in vogue now. But you will have to adapt dispositions to make sense of the relation between trigger and manifestation in an original way without losing the notion of identity. So, a lot of work to do. Thank you very much. These are my sources.
Yes, thank you. We have about 15 minutes for questions and discussion. So please, if you have a question or want to make a comment, raise your hands. And I think we also adopt the convention that you can raise a finger or a follow-up, if that's totally related to the question that was asked before. Okay, Emily, can you
I wanted to ask about, you sort of talked about the idea that irreversibility and asymmetry requires.
Sorry.
You talked about the idea that irreversibility and asymmetry requires like a local privileged direction of time. I wanted to ask more about what kind of privilege you're referring to there. Like, if for example, I understand irreversibility to come from underlying time symmetric dynamics plus averaging over a large number of particles and some special kind of initial state. There's going to be some kind of
No,
emergent
but that's not option 2, that's option 1.
Right.
That's starting from reversible
Yes.
and explaining it, so that's option 1.
Yes.
Option 2 is that local time direction is a fact. You don't need to explain it. You have to explain why time reversible physics works.
Right. I was just.
I'm not saying you should be option 2. I'm just saying if you adopt option 2, that's Prigogine would say that's what you have to do.
Okay, so you're not just inferring from irreversible physics directly to there must be a privileged direction. You're going through the assumption that we're taking.
Okay. My point is that if you buy the option 2, because option 1 is what we do. What we do is option 1. If there's a time direction, we have to explain it because physics does not see time, does not see direction of time. Option 2 is that there's a time direction. That's a fact. What you have to explain is why the specific physics that is time reversible works so well. And if you have the difference of time, the static definition of change, you don't have a direction in that, so you have to add one. But this privileged direction will be given by the world because it's a fact.
And it sort of seemed like you were appealing to irreversible physics to justify taking option 2. I guess I wasn't quite seeing where that justification.
I think both. You know, I think Prigogine. That's the thing. It depends what you call fundamental in physics. And since I don't believe in fundamental physics at all, if you start, okay, what is fundamental physics? Basic quantum mechanics, basic classical physics. You have no direction, and after that you try to explain direction of time, and it's a valuable project, statistical, blah blah blah. But if you start from from all these branch of physics, far from equilibrium, thermodynamics, all that, they start with direction of time and they build after. That I don't know. Okay, it seems to me valuable because in a certain sense maybe the universe is a big thermodynamical system and that would give us a direction, at least a local one, for free. And after that explain why when you look at small system, isolated system, we have this insensibility to the direction, this symmetry. But that's a philosophical choice. I'm just putting that there because I believe that, especially in philosophy of fundamental physics, and here I look at Christian, we all been trained with quantum mechanics, general relativity as physics, and not all these stuff as physics. But these stuff has a lot of success in the last 60 years. A lot of empirical success. Dissipative structure is a great thing. So I don't know. I'm just putting this option on the table. Yes. I don't know. You're controlling the question.
Follow up.
It has to do with the reversible systems in a sense.
If you're confident that it's a follow-up, then go ahead.
Happy to count it as a follow-up. Can you say something more about why you think that there is any real difference about the chronal change, the explanation for change, in the reversible and irreversible case? Because my understanding in both situations in physics, you assume some notion of time with all the possible issues with general covariance. Therefore, you assume changes defined by that and primitive in a sense. And it just happens that for some systems that change is reversible and for others is not, and you describe them differently. And there's of course a lot of differences in physics, but from the point of view of the metaphysical explanation of change, I don't really see a difference.
Okay. Sorry. I'm losing my voice. Yeah, in the practice of physics, we usually put the direction of time by hand, which is what we do often, because depending on what we want to represent, and we can look at the reverse for simple systems at least. Big systems is quite difficult to see the reverse. We have to claim bizarre thing like ergocity. So I don't want to discuss practice. I think the practice is good. The people, what they do, they model stuff and they try to get to prediction, and that's okay. But why I worry metaphysically is that there's a difference between time change as difference, which has no direction of time intrinsic to the definition. Time is just an index. And time as becoming. Time as becoming, change as becoming is a change with the direction. Maybe not temporal, but a direction that is there.
But understand there are two different notions of change. I
Yeah.
don't see why these two different notions would suffer more or less
Okay.
with respect to the issue of
Because
their own
okay,
explanation.
because you're right. In Lewis, it's time as difference, so he does not care about the direction of time. In Armstrong, the basic level is causal relation, and Armstrong understands causal relation as time directed. So maybe there's a problem there, but especially if the universal are not indexed, maybe not, maybe yes. If they are indexed, it will be worse. We will have to explain. Maybe time will be part of the index. I think it will be maybe contextual, something more complicated than just an index. And for primitivism, it's okay, but for dispositionalism, there's clearly a direction between trigger first, manifestation second. So there's an intrinsic direction here that has to be reconciled. If we say basic physics is time symmetric, it's explained metaphysically by that, and this is not time symmetric, there will be a mismatch too. So each time, okay, here I try not to adopt, I try to give you the different position, but if you think the fundamental physics is time reversible, this won't satisfy you. So it's the mismatch between the different explanation and what you assume to be the message that physics provide us about change.
And so it would be a difference in explanation within this type of
For example, if you want to adopt dispositionalism for quantum gravity, you will be in trouble. You will have to change the definition to make it accommodate the thing. Which is important because now disposition is really used for chemistry more and more. People are defending more and more disposition as a good approach to understand the basic metaphysics of basic science like chemistry, but does not seem to be really accommodating what we say in general relativity, for example.
Chris, you next up on this.
Thanks. So you've listed a number of difficulties with various approaches to laws of nature, and you've acknowledged that these may not be difficulties that cannot be resolved. So
I hope most of them are resolvable,
Okay.
but they will be tough. They will be
So
tough.
let me sketch some resolutions on behalf of Lewis for the three difficulties you raised. So the first one was that given that there's geometry in the
mosaic.
human mosaic, it seems as if you already need antecedently to have the laws so that you could describe or determine the geometry. And I think that's not how I understand Lewis. I understand Lewis is claiming that it's really the fundamental, what's fundamentally there, what's ontological or metaphysically prior, is the mosaic, which includes the geometry. So it does, this is in a sense, it's primitive. That's where the bucket stops. That's where you cannot ask where does it originate or something like that. That's just the end of explanation. And then you crank this into the whole machinery of best systems, and then you get the laws. So in a way, this is an illegitimate question on the Lewisian approach.
I'll let you finish, I will answer after.
Yes, okay.
Don't
So
say
that
it's
would be a Lewisian response to that. This is just not a question.
Okay, so the mosaic of fact is facts organized. Or do you want to do all your...
no, you can do one by it.
So it's fact organized in a geometrical structure, and you say it's first. And it was first in his mind because he was defending some block universe. He talked to physicists, and they said the universe is a block. They said, okay, so there's a mosaic of facts. But this mosaic of facts, I do the work of the laws on it. Let's imagine, and I get to loop quantum gravity, which says that the mosaic of facts that you use, measurement indexed by space and time, because it's what we do when we measure, is not okay.
Sure, yes.
So, what is this mosaic?
So, that is of course exactly right. If you have no space-time fundamentally speaking, then the human mosaic becomes a question. Yes.
But I agree.
So
For the list, it's a brute
I
fact.
didn't take that to be the question.
It's a brute fact. I agree. It's a brute fact. It's the start of the thing. It's the mosaic of facts. The problem for me, it's not. It's a brute fact. I accept it. But if I get to the laws that says that it cannot be the brute facts, it's where I find difficulty.
Right. No, of course.
Okay. Your second one?
The second one was the second difficulty about supervenience not being sufficient. I completely agree, and I think probably Lewis would as well. I think you need more than that. You need the best systems machinery to really get out the laws. So clearly there must be something, supervenience, as you rightly said, is just too weak a relationship. That's not going to be enough.
But I worry about what Lewis would have said, because when he discussed that he does not want more than supervenience, he wants methodological reduction, it's because he worried that the best system will very be difficult to define uniquely if there's something like rich emergence of property at macro level, for example. So it's a cost benefit. He says, okay, for it work, I must adopt this methodological one, but of course, it seems it's not enough. So how do you guarantee that the best system will still work as a technique if you have rich not just a mosaic of basic perfectly natural properties, but things more complicated as a richer mosaic?
So, again, if space-time is not fundamental, we run into problems with the program, of course, that is clear. But if it is, then it seems to me that the best system at least has a shot of being sufficient to generate the laws. And the third...
No, but they are all I insist, they are all very good, I think, proposition of what are natural laws. It's just how to accommodate it. Okay, sorry, I cut you.
Right, so and then if change is directed, so now, of course it seems obvious to me that Lewis would go along with some sort of reduction of the direction of time to some, basic principles in the best system, and maybe one of the assumes that the best system might be some sort of past hypothesis, together with, I don't know, time reversal learning dynamics, and then maybe you get some sort of asymmetry out of that. I mean, that's then left in a way to the physicists to figure out how that's supposed to work, but maybe something like that could be done to work.
So I think this, I concede that point. I think that what a Lewisian will explain the direction through something like past hypothesis. The question is that does it work for the entire mosaic? Or is it always local direction in the mosaic?
I'm afraid we are out of time, so we're about to head into the coffee break. Please join me again in thanking our first speaker.